All right, so here's a pretty typical displacement problem. You're asked, you're told you leave your house, you go 10 kilometers north, then 8 east, then 15 south, and then 20 west. Draw a vector diagram and determine your distance and your displacement. So distance is how much ground you covered. How far did you go? I don't have to draw a picture or do much of anything to find out how far I went. I went 10 kilometers plus another 8 kilometers plus another 15 kilometers plus another 20. So that's 53, I think, would be my distance. So I can actually just write that right up here. Distance is 53 kilometers. So if I was looking to get in shape or something, I could calculate that. I might care about the fact that I went 53 kilometers, which is the distance that I traveled. But my displacement is how far am I? At the end of this event, how far am I and in what direction am I relative to where I started? So for this, I'm going to have to draw a vector diagram. All a vector is a quantity that has magnitude and direction. And a vector diagram just shows the magnitude of all these different displacements and their direction. So I'm going to mark my starting point with a dot here. It's helpful to know where you started. And I'm just going to, one step at a time, draw a picture of this trip, draw a diagram for every step of this trip. So I went 10 kilometers north. So from my starting point, I'm just going to draw an arrow up, and that'll be a 10 kilometer distance. It's a pretty sad arrow, but that's 10 kilometers due north. Then 8 kilometers east. Well, 8 kilometers is going to be less than 10 kilometers. I'm not going to get out a ruler, but I'm going to try to make this arrow just a little shorter than the other one. So that's 8 kilometers east, then 15 south. If this is 10, then this 15 south is going to be 1.5 times that distance, 1.5 times that length. So I'm going to try to draw that approximately proportional. And finally, 20 kilometers west. So if this eastern displacement was 8, 20 is going to be what compared to 8? It's like 2.5 times 8. So I'm going to try to make this 2.5 times the distance. So it's going to be somewhere around there. So this will give me an idea of what this trip looks like. This is not done. I would not give you credit for this, and I don't think this would be particularly helpful to you if you were doing a complicated problem. You want to label all these arrows so that you know what they are, you know what their magnitudes are. So first we're going to label this. This was 10 kilometers. This was 8 kilometers, and I don't have to put the direction because the arrowhead showing the direction. This was 15 kilometers, and this last displacement in the western direction was 20 kilometers. So this is my trip, and I want to know, you're asked to find displacement. Displacement is how far are you from where you started and in what direction. So here is where I started, and here is where I ended up. So I drew it in a different color. If you were drawing this on your paper, you could maybe make it a dotted line to indicate that this is our unknown. This is what I'm trying to find, is this displacement. We are usually going to represent displacement with the letter X or the letter Y, but in this case, we're going to use S. And you'll see it oftentimes when it's introduced, when the idea of displacement is introduced, you'll see it shown with the letter S. So this is the displacement, and how do I calculate this? Well, what I see if I look at this is a right triangle is in here. So let me draw that right triangle. I'll try to do a dotted line here. Right, that's one side of this right triangle. That's one of the legs, and here's another one of the legs. So I can see that I do have in here a right triangle, and I know the dimensions. I know the lengths of these legs. I can kind of figure it out from the information I'm given. So if I know that the magnitude of this vector is 10, and then it went 15 down, I know that this little section of it here must be 5 kilometers. If this is 8 in this direction, and then it backtracked 20, then this section of it here, right, this part right here, must be 12 kilometers. So I have a right triangle here with legs of 12 and 5. So I can find this. This would be the hypotenuse, right? It's opposite that right angle. That would be the hypotenuse, and I can calculate that using the Pythagorean theorem. So here I'm going to find the magnitude of the displacement. And displacement I'll just abbreviate with an S. So the magnitude of the displacement, and by magnitude I just mean how much is it? How many kilometers is it? Magnitude is not including the direction. I'm going to have to find that separately. So I just use the Pythagorean theorem. It's the square root of 12 squared plus 5 squared. And when I put that in the calculator, I get 13. And look, I put my units after my number because this is 13 kilometers. This displacement represents 13 kilometers. So is that your whole answer? No, that is not, right? That's not your full displacement. Your displacement is going to tell somebody, relative to some other point in space, where are you and in what direction? How can they get to you? So let's look back at this problem that says you left your house and you went 10 kilometers north and 8 east and 15 south and 20 west. Let's say that you call home. So this would be your house. This is where you left. This is your house. We'll draw a little house here. And you call home, and here you are. You're over here, 13 kilometers away. And you say, listen, can you come pick me up? I'm tired. And can you come and get me and give me a ride home? And maybe somebody says yes. And they ask you where you are. And you say, well, I'm 13 kilometers away. Is that going to help them find you? Is that going to allow them to find you? So if all you say is I'm 13 kilometers away from home, that puts you anywhere on a circle with a radius of 13 kilometers. So it puts you anywhere. I'm not drawing the best circle here, but it puts you anywhere on this circle. And who is going to come looking for you at all points on the circle with a 13-kilometer radius relative to your home? And the answer is probably nobody. They're going to want some more information from you. 13 kilometers in what direction? So if you called home and you said, come get me, I'm 13 kilometers away, you have to tell them in what direction. When you leave home, which way do they have to go if they wanted to get you? So I can figure this out too, right? I can figure this out in terms of my compass points, north, south, east, and west. So let's take a look at the compass and let's see if we can get some idea about how to calculate this. So I'm going to put your house here right in the middle of a compass. So let's say that this is north and this would be east. This is a tricky one. And here's west and here's south. So these are these compass points relative to your house. So here's north and here's east and south and west. So you're here. You're here, and you can say, well, I'm southwest. I'm 13 kilometers southwest of home. And that would still put you, if we extend these compass lines here, that would still put you anywhere along this arc here. If you just tell them I'm 13 kilometers away southwest, well then, it narrows it down, but it's still a pretty big area that they would have to cover to come find you. So you need to be more specific, and how we're going to be more specific is you can actually, and we actually know how to calculate this angle here, theta. So you could call home and you could say, well, I'm 13 kilometers away at this angle relative to south or relative to west. This would be relative to south. But let's calculate this angle here. I'm going to rewrite the triangle over here. I'm just going to make it a little bit neater up here. So we had a triangle with a side that was 5 and a side that was 12 and a hypotenuse that was 13. This was our right triangle. And here's my theta. And this is 5 and 12. And I know this is 13, but I'm not going to use it in my calculations because I try not to use anything I calculated to calculate another value with if I can help it. So what trig function am I going to use? Well, let's take a look here. I have, this is my right angle. I know opposite that is my hypotenuse. I know that the side of the triangle that makes up the angle theta is the adjacent side. And I know if I start here and I go across that 12 would be opposite. So I'm not given hypotenuse and I'm not asked to find it. So what trig function has opposite and adjacent in it? Would be the tangent function. Tangent of theta is opposite over adjacent. I don't want to know the tangent of theta. I want to know theta. So theta is going to be the inverse tangent of opposite over adjacent. And that is going to be the inverse tangent of 12/5. And when you solve for that, you get 67 degrees. So we're getting there, right? So you said, well, I'm 13 kilometers away from home. I'm at 67 degrees southwest. Well, let's take a look at southwest here. If this is my compass and this is the angle you just found, southwest, does it mean this angle if you just told the people at home? Or does it mean this angle? There's two angles in here. There's this one and there's this one. Now we calculated this one, and this angle up here would be the complement of that. But you have to specify which angle are you. So here's west and here's south, and you want to indicate that this is the angle that you calculated. This is the 67-degree angle. How would you indicate that? You would say, well, relative to south, you're going to go west. To make this angle from south, you're going to go west. So this angle would be a west of south angle. And that is the last piece of information you need to give your complete displacement. So how would I give this answer, a complete answer here? I would say, well, my displacement is 13 kilometers away at 67 degrees west of south. And that puts you at a particular place relative to your house and no other place. That puts you at this particular point.